All right, hello. This is going to be a video on segment addition postulate. And for those of you who've not heard of a postulate before, a postulate is a statement taken to be true, usually been put through the ringer by mathematicians, if we're talking about math specifically, proving it and trying to see if it's not true, and nobody's been able to find that it's not true, and that it's, so we're taking it as true because nobody's been able to find out that it's not. So it's basically just like a true statement. All right, so segment addition postulate, we know this to be true thus far in life. Maybe somebody will disprove it someday, maybe not. All right, so the segment addition postulate, what it is you're adding segments, and specifically you're adding 2 segments. You're not adding 3, 4, 5. I mean, you could actually, that doesn't matter. Yeah, you could add a whole bunch. The point is you're adding little segments to be the big segment. So the segment addition postulate is basically saying, well, I have 2 little sections and a whole segment. So one way to look at this is I have this segment AB, and then I have this segment that was super crooked, but we're going to go with it. And then we have the segment BC. And if I add those together, if I combine them like they are here, then I get, right, if I add those, then I get the whole thing, which is AC. Right? If I combine those, I get this whole thing. All right. So AB plus BC equals AC. All right. So little segment plus little segment equals big segment. I get this little chunk plus the little chunk equals the entire thing. Okay. So let's go through some examples. I got 5 examples. We're going to go through how this is going to be used. So if I want to find out RT, so if I want to find out RT, I want to find out what that equals. Well, I know it's equal to RS plus ST, because RS, this little chunk, plus this little chunk make the whole thing. So by using the segment addition postulate, I can add the 2 little pieces to be the big thing. Well, I can then use substitution of what is RS? RS is 105. What is ST? 10. So RT equals 115. So RT equals 115. Okay, and usually, we'll throw in inches, miles, centimeters, whatever. But in this case, we just got the numbers. The point is you take the little chunk, which is 105, plus the other little chunk, which is 10. So 10 plus 105, 115. All right, pretty simple. Then we get the next difficulty, right? We're going to work our way up in difficulty here. Now, we're actually given, so let's just write this out in the segment addition postulate using just letters. The best way to start this is using just the letters and write this out. I have a little chunk, AB, plus another little chunk, BC, equals the whole thing, which is from A all the way to C. All right, so I want to find what BC is because I don't have a number there, but I do know what AB is, and I can substitute that in. AB is 40. So I get 40 plus, I don't know what BC is. You don't put 80 there. 80 is not BC. 80 is A to C. BC is not 80. I don't know what it is. I don't know. Maybe it helps if you draw a question mark there. Like, that's what we're trying to find. I have no idea what it is. So I just keep it as BC. Equals, well, I know what AC is. From A to C, it's 80. So now you just solve it like you normally would. Like, how do I get rid of a positive 40? Minus 40, minus 40, crosses out, and I get BC equals 40. All right? So that was the next difficulty. The other one, it was just there for you. You just add the two numbers. This one, we had to set it up and then subtract. This one gets a little more intriguing of now we have a variable and I'm not solving for, actually I need to give these some letters. Let's do E, F, G. And now I'm not solving for a segment. I'm actually want to solve for X. So what I want to do is what you should always do is start off by writing with just the points. So EF plus FG equals the whole thing. So from E to G. All right. Now all you do is you substitute in what you know. I know what EF is. EF is 2X. Plus, I know what FG is. FG is 3X. And I know what E to G is. It's 30. So now you have an equation and we can solve for X. So combine like terms. Cancel out. X equals 6. Now, if I wanted to go a step further, I could actually have you take that, or your teacher could have you take that and plug it in. And if you get 2 times 6, that gives you 12. And then 3 times 6 is 18. And what do you know? 12 plus 18 is 30, right? Okay. So I grab the mouse like that's how I move it. Okay, grab the next piece of paper. Now this one, example 4, this one's not even going to have you solve anything. This one wants you to just write the expression for xz. So again, I start with just doing the setting up the addition postulate with just the points. Little chunk xy plus the other little chunk yz equals the whole thing from x to z. Okay, well I know what xy is. Xy is 3x, so let's substitute in 3x for xy. So 3x. I also know what yz is. It's 20x minus 8. So let's add in 20x, and I'm gonna, I actually also want to put parentheses around it, minus 8. Because I substituted in, whenever you substitute in more than one thing, right? I substituted in one thing, so I didn't put parentheses, but I substituted in 2 terms. So I'm going to put parentheses around it just in case, might not matter. I don't know what xz is, which is the whole point. I'm writing an expression for xz. Okay, so the reason why I did that is because it would matter if that was a negative, but that's not a minus sign, that's a plus sign. So the parentheses actually don't matter. So I can just drop them. So 3x plus 20x minus 8 equals xz. You can skip that step if you want to skip that step. But if that was a minus, you would have had to distribute it. Now you can combine like terms. So I get 23x minus 8 equals xz. So the expression, I don't want an equation. This is an equation right here. I don't want an equation. I just want the expression. And the expression is 23x minus 8. Right, key word, guys. Key word to whoever's watching this video. My students have definitely had vocab on what the difference between an expression and an equation is, and the difference is an equal sign. This is an expression. That is an equation. Expression, equation. Okay. Now the last one's a story problem. Still, I think pretty simple. It's just adding and subtracting. So what is the distance from Tulsa to St. Louis based on the given info? Okay, so I have my points, L for Lubbock, T for Tulsa, S for St. Louis. So I get LT, which is a little chunk, plus the other little chunk, which is TS, equals the whole thing, which is from L to S, which is Lubbock to St. Louis. Okay, so I want to find TS. I don't know this, right? That's the question is I want to find the distance from Tulsa to St. Louis. I want to find this distance. Don't know what it is. But I do know LT. That's 337 miles. So 337. Plus, again, I don't know what TS is, but I do know the whole distance from Lubbock to St. Louis. So from Lubbock to St. Louis, 738. Now, all I gotta do is subtract. So minus 337. Minus 337. Cancels out. I get TS equals 401. I'm going with 401. So my answer wouldn't be just 401 like this. I wouldn't circle this. I wouldn't type this in. My answer would be 401 miles. That is the distance from here to here, 401 miles. All right, using the segment addition postulate. So hopefully this video is helpful to my students for their segment addition postulate problems. And hopefully it was helpful to anybody else who happened to come by this video. So thank you for watching.